Welcome back, everyone. Unit 5, Lesson 2. Today we're going to be talking about linear versus non-linear relationships. I believe there's probably going to be at least two parts to this video. So this is part 1, part A. Let's get started. Part 1, finite differences. What are finite differences? Finite differences are used to determine if a set of data represents a linear relationship. The first differences are calculated by finding the difference between consecutive y values in a table. If the first differences are constant, the relationship is linear. If they are not constant, the relationship is non-linear. Note, these conclusions about linearity can only be drawn if the x values in the table increase by a constant amount. And we're going to start with example 1. But I just want to highlight this again. Very important. The x values have to be going up or down by the exact same amount. What do I mean by that? Well, here we have x values are 0, 1, 2, 3, 4, 5, 6, meaning they're going up by 1 each time. If my x values were listed 0, 1, and then like 5, and then 7, and then like 20, they're not going up by a constant amount. They're going up by like a random amount. So that doesn't, we wouldn't be able to do first differences in that example. But for this example, because my x values are going up by the exact same amount each time, we can take the differences, meaning subtraction, differences means subtraction, of our y values to figure out whether this relationship is going to be a linear relationship, a straight line, or non-linear, not a straight line. How do we do that? Easily. We first extend our table. So we have our table of values, x and y. Then we draw a third column here and give it a little bit more room because we have to do a little bit of calculations. And we usually block out that first row there and that new column that we made it because we need to calculate the difference between two values. And those two values are always going to be the value here, which is our second row, and we subtract it from the value above. So our first difference is going to be 2 minus 0, which of course is just 2. And then we continue this pattern. We look at this value here, which is 4, and we subtract the value above, which is 2. So 4 minus 2 is 2. And we continue doing this. We have 6 here, 6 minus 4, which equals 2. Here we have 8, 8 minus the value above, which is 6, which is 2. Here we have 10 minus 8, which is 2. And finally 12 minus 10, which is 2. So in this example, because our first differences are all constant, meaning the same value, they're all 2's, this relationship should be a straight line. And we are going to graph it to prove that. So our first point is 0, 0, which is origin, which is right here, 0, 0. Our next point is 1, 2. X value is here, y value is here. 1, 2 is 1 here, and then 2. Next is 2, 4, so 2 and 4. Next is 3 and 6, so 3 and 6. 4 and 8, 4 and 8. 5 and 10. And finally 6 and 12, so 6 is here, and 12 is all the way up here. So if we were to draw a line, you can see that that is a linear relationship, meaning it's a straight line. That's it. All right, let's move on to example B now. First, always check to see if our x values are going up or down by a constant value. In this case, we have -3, -2, -1, 0, 1, 2, 3. So they're all going up by 1. That means we can do some first differences. So let's do this. This is going to be 4, value here, subtract from the value above, 4 minus 9, which equals -5. Very important. You are allowed to have negative values. Do not be afraid of them. 1 minus 4, which is negative 3. 0 minus 1, which is negative 1. Now we have 1 minus 0, which is 1. 4 minus 1, which is 3. And 9 minus 4, which is 5. Clearly, you can see that the first differences are not constant. So this table of values does not represent a linear relationship. And we're going to graph it to prove that, further prove it. So negative 3 and 9. So remember, this is our x value, x-axis, sorry, this is our y-axis. Negative 3 is here, and 9 is all the way up here. We have negative 2 and 4, so negative 2 and 4. Negative 1 and 1. 0, 0, that's here. 1, 1, so that's 1 and 1. 2 and 4, so 2 and 4. And 3 and 9. If we connect the dots, connect all our points, we can see it's kind of curving and making a shape like this. Draw some arrows there. So this is a non-linear relationship. It's not a straight line. Rates of change and linear relationships. A constant finite difference means that the relationship has a constant rate of change, which represents how much the y value increases or decreases for every unit increase in x. Since all linear relationships have a constant rate of change, their first differences are always the same when the x values are evenly spaced. The rate of change, often called the slope, describes how one quantity changes in relation to another and is a key characteristic of linear relationships. The general structure of an equation of a linear relationship is y equals the rate of change times x plus starting value, or y equals mx plus b, m times x plus b. M is your rate of change, also known as your slope, and your y is your starting value, also known as the y-intercept. Let's do an example. Example 2. Two friends, Rory and Cal, are saving money from their part-time jobs. Rory starts with $0 in savings and earns $20 per hour. Cal starts with $100 in savings and also earns $20 per hour. Complete the table of values for each friend, then calculate the finite differences to check if there is a linear relationship between the variables. So we have the table of values. Let's do our first differences. First differences and finite differences are the same, just in case you're wondering. So we start off with 20 minus 0, which is obviously 20. Then we have 40 minus 20, which is 20. 60 minus 40, which is 20. 80 minus 60, which is 20. 100 minus 80, which is 20. And 120 minus 100, which is also 20. All right. So our first differences are all 20, meaning the graph for Rory, or the relationship, is linear. For Cal, we have different values. So let's see if this is also going to be linear or not. We have starting with 120 minus 100, which is 20. Let's continue. We have 140 minus 120, which is 20. 160 minus 140, which is 20. And 180 minus 160, which is 20. And you're going to realize that, you know what, they're all 20. What does that mean? Because Cal has saved up more money, $220, and Rory has saved $120, but the first differences are the same. Let's see what that means. Well, I'm going to graph both of these values on this graph here. And the first value for Rory was 0, 0. And the next value was 120. Then it was 240, 360, 4, 80, 5, 100, and 6, 120. So that was it. 0, 0, 120, 2, 40, 360, 480, 5, 100, 6, 120. Here we have 0, 100, 1, 120. So 0, 100, 1, 120, 2, 140, and 3, 160. So 2, 140, and 3, 160. 4, 180, 5, 200, 80, 5, 200, and then 6, 220. So here. So you can clearly see that these lines are different, but their finite differences are the same. So when we're talking about the finite differences being the same, that's the slope or the rate of change. Slope meaning the angle or slant of our line. So here we have the slope of 0. When something's more steep, the slope or angle goes up. So there, we're saying that this slope right here is the same for both lines, and you can see then that makes sense. The slope is the same, even though their starting values are different and each value in the table is different. The slope is the same, meaning the angle at which they're kind of going up. Now we're going to write an equation relating money saved to hours worked for each friend, and we're going to calculate how much money they will have after working 40 hours this week. So the equation is very simple. It's y equals mx plus b. And I'm going to get the table once more. All right, so we have the tables for Rory and Cal. Y equals mx plus b. Remember, b is our starting value. What does that mean? That means when x is 0, whatever value is y, that is my b value. So in this case, my b value is going to be 0 for Rory because x is 0 and y is 0. My slope is going to be what the value is here, and that's 20. So the equation is y equals 20 times x plus 0. And remember, we don't really need to write plus 0 because it doesn't do anything. So the equation for Rory is y equals 20x. Now for Cal, x is 0 and y is 100. So that means my b value is 100 for the equation for Cal. And in this case, the m value, the slope, is 20 because it's the same. So the equation is y equals m times x, so that's 20 times x plus 100. That's how the equations are different. The slope or the rate of change are the same, but the initial value, the starting values, are different. And the question asks us to calculate if they worked 40 hours a week, how much would they have saved? So that's very simple. 40 hours is x's hours worked. So we're going to plug in this value for x. Y is money saved, which is equal to 20 times the hours worked. And if they tell us the hours worked is 40, we know that this person is going to save $800. Now it's slightly different for Cal because the equation is different. It's 20 times 40. The number of hours is the same. And that's going to be 800 plus 100, which is $900. And that's it for part A. Make sure you join us for part B. Thank you.